Hi everyone, and welcome to our video on standard deviation. This is part of our Module 4 Part 3 series looking at classification and evolution. And more importantly, this focuses on one of those basic math skills that they expect you to be able to carry out on your A-level papers. So this is looking at specification reference M1.10, so one of the math skills, understand measures of dispersion including standard deviation and range. First thing then, we need to understand what this standard deviation thing actually is. And quite simply, standard deviation is just a measure of variation. So we're looking to see how much the data spreads from the mean value. Now, what we're going to see then are two pretty distinctive graphs. So we've got our first one here, and I'm just going to try to draw over it so we can see it a bit clearer, which is a low standard deviation. So we've got our mean value at this high point at the peak, and then we actually have a narrow spread, a narrow range. So basically all of those data points are close to the mean. And if we get a low standard deviation, that tells us that there is only low spread from the mean, and this means that our data is more reliable. If, however, we get a different shape graph like the one at the bottom, then we have a high standard deviation. So our mean point is again in the center, and we've got quite a wide range of data points. They're not grouped closely to the mean, and therefore this data is less reliable. When it comes to actually calculating standard deviation on your papers, the good news, you're being given the formula. So if they want you to use it, you will have that formula printed in the actual question space. The things they're not going to print are here. So they will give you the formula, but they're not going to tell you what any of these bits actually mean. You're meant to know that bit. So let's break this formula down to make sure we understand what we need to do first of all. So S is our standard deviation, and that is the square root of the sum. So remember that little Greek sign there means sum of, and that is X minus X bar. So X is an individual value, X bar is the mean, and we're going to square that. And then we divide that by n minus 1, where n is the number of data points. So as I've said, we don't need to learn the formula, we just need to know what those bits actually mean. So if you're asked to calculate standard deviation, what do we do? Well, there's 5 simple steps in all honesty. The first one, you just need to calculate your n minus 1 using the sample size. So you count up the sample size, take 1 away from it, and that is your n minus 1 value. You can then calculate the mean, so obviously add up all of those individual values and divide by however many there were. We're then going to calculate the X minus X bar squared. So what that means is for each data point, you obviously need to do your data point minus the mean and square that for each value in that table. We then add all of those together, and then we can substitute the values that we've calculated into the formula. So typically we'd get given a little table. Sometimes they will give you the actual outline for other columns. Other times you can just add them in yourself. So in this case, we've got all of our data points down here. And if we count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we're doing our n minus 1, that's obviously going to be 10 minus 1, which gives us 9 first of all. Then we obviously need to calculate our mean, the X bar. And to calculate our X bar, what we need to do is add up all 10 of those data points and divide by 10. So once we've calculated our mean, which I've worked out as 84.6 in this case, then what we are going to find is we then need to use that for each of our individual values. So what we need to do is each value minus X bar, so minus the mean, and then square it. So I've broken this down to show you how we're doing it in each of these columns. So for our first one, we do 89 minus our mean, 84.6, and then we would square that, which gives us 19.36. You do that for each row of the table. Once we've got that all squared, what we then do is we are going to add this entire column together. So what we are then going to end up with is a value of, I do believe, 726.4, and then we can substitute it into our formula. So remember, what we need to do is our square root of the x minus x bar squared, which we've summed, which is 726.4, divided by n minus 1, which was 9, and that gives us 8.98. So what that means is that our standard deviation is 8.98. Now, if we've got that, it means that the spread of the data is either plus 8.98 or down to minus 8.98 from the mean. So what we're really looking at there is obviously our mean value of 84.6, and it's going to go up to a high point of that plus 8.98, and then the low point is going to be that minus 8.98. So that gives us kind of like the maximum and the minimum values. So remember, this little sign here, plus or minus, means that it's either going that much above or that much below your mean value. So what does this actually tell us? Well, in a normal distribution, what we should find is that 68% of our values should lie within one standard deviation of the mean. So if we have a look at the little graph at the bottom, that's the green bars in the center there. Okay, so we've got obviously 34% below, 34% above, but 68% in total lie just one standard deviation from the mean. If we take that to 2 standard deviations from the mean, then that would be 95% of all values that we should find there. If we've got any of the values that fall outside of that 2 standard deviations from the mean, we can describe that as being potentially anomalous, because we would not expect data to really be that far from our mean value. So if we do have one that's over that, we could probably identify that as being an anomaly. Now, one of the other aspects that we can see coming onto the A-level biology paper is using graphs that have information like standard deviation on it. So when we've got our graph with standard deviations, we always show it as this bar. Now, obviously, because it's a standard deviation and we're looking at the spread from the mean, it's going to have the same amount of space above as it does below the mean. So on our bar charts, we can see obviously the mean value is the top of the bar here. And then we're going one standard deviation above, one standard deviation below. So that's representing that vertical bar that we can see. When we're interpreting these graphs, if the bars are overlapping, then it's likely that the difference in the means is due to chance. So this case on the left here, we can see we've got 2 different bars for our standard deviations. They are both overlapping, and therefore the difference in those is probably just down to chance. Whereas the graph on the right hand side, we can see that the standard deviation bars do not overlap. So what we can see here is that it's unlikely that the difference in those 2 means is actually down to chance. There's something else causing that difference. As always, I hope you found this video useful, and of course don't forget to subscribe to the channel so you can see when the next video is uploaded, and head on over to the website where you can find a range of other resources to help you in your A-level biology studies.